Unlocking autonomy. Is that my feedback? Okay. Unlocking autonomy, exploring the integration of AI algorithms, sensors, technologies of Waymo autonomous vehicles by Cynthia Los Santos and Andrew Ma. This is our team.
So much emerging technology is just a show. So one can be forgiven for not being able to distinguish fact from fiction. Take this car, for example. Can it drive autonomously or not?
The short answer is absolutely.
So Waymo's self-driving vehicles use advanced AI and variety of sensors to understand their environment, use machine learning algorithms, and vehicle make real-time decisions by analyzing factors like traffic conditions, road signage, and the integration of AI allows Waymo to continuously update high-definition maps, improving navigations, route planning, prioritizing safety. Waymo's AI algorithms predict the actions of pedestrians, cyclists, and other drivers, implementing safety measures into as emergency braking and collision avoidance. So here's a timeline of Waymo, and Waymo, it was a part of the Alphabet incorporated by Google and started in 2009. In 2015, it was the first fully autonomous car on the road. Waymo has become an independent technology company. Waymo's early rider begins in Phoenix, Arizona in 2018. Waymo's One is launched, and Waymo in 2020 opens their rider-only service in 2021. Waymo's test program begins in San Francisco. 2022, Waymo offers rides only in San Francisco, and Waymo offers the first ride service to the airport in 2023. Waymo offers its first rider service in Los Angeles and goes fully electric and expands the Phoenix service area.
Okay, so I'm going to be talking about the AI algorithms behind Waymo. There are regression algorithms that we use. There's neural network, Bayesian regression, and decision forest regression. Yep, so this is a picture of a neural network for this complicated brain. Okay, let's see. Okay, this is another picture. Okay, so pretty much a neural network is a method in artificial intelligence that teaches computers to process data, and it's inspired by the human brain. For example, YouTube, you know, the stuff everyone watches on everything, you know, there's like the watch next button, or like the watch, or could be any recommendations in general. The AI is powering all that. So neural network is a series of algorithms, and it is used to recognize underlying relationships in a set of data and process that mimics the human brain, the way how it operates. Okay, here's one. So, neural network is a type of machine learning algorithm. It can be used from taking a trained set of input data, and it takes that data and then it spits out output data, which is called neural network model. So this is pretty much what the whole neural network regression is all about. So a model is trained by adjusting the weights of the connection, and it uses that data to accurately predict the output. Let's say, for example, if you want to predict, let's say in real estate, the price of a house, or the size, location, or other features of this model, this is a classic example, but a regression model would be also known in statistics too as regression. So same beast we're dealing with. I remember the other group, they were talking about how AI robots might take over, and this auto robot I actually saw the other day in LA, and it's very phenomenal because its mind, it was about to get hit by this one car, but phenomenally. It was able to dodge that car, and I was extremely shocked. But AI is getting very smart. So neural network regression is a machine learning algorithm predicting, adjusting data. Model training, it takes this black box input data and produces an output. Regression problem is predicting a continuous output, and contrasts as classification problems, which I will show in the further slides. Yeah, and that's pretty much it. Let's see. So this is Bayesian regression. So I use the Dolly 3 AI. It's powered by Bing Copilot, so it generates these images just for you to see. So what is Bayesian regression? So a phenomenal question, or a good question I was trying to ask the other day. I used chat. I was asking, is Bayesian regression combining previous Gaussian distributions in new one? And chat somehow came up with an answer and said, yeah, it's a really good way to think about it, combining prior distributions. So you're taking previous knowledge and you're using that and you're combining it to get new knowledge, and yeah, and that's how you get the new curve and whatever it is. Prior distribution to gain the posterior distribution. I'll sit there. Okay, if I would have more time, I would go into Bayesian regression. This will be definitely further researched. It's a very fascinating topic. This is the math behind it, complex. This is I'm gonna go over the second one. So decision forest regression is a machine learning algorithm used for predicting continuous target variable based on input feature. So decision trees have a hierarchical structure resembling an inverted tree, where each internal node represents a decision based on a feature. Each branch represents an outcome of the decision, and each leaf node represents the final prediction. Here's just another picture. Pretty much it goes to, makes a bunch of data analysis, and it's like, boom, we're getting the final class for it. Okay. So this right here is regression versus a classification task. The other day I found some more research because I was in my stats class, so I was studying this. So regression is like you're taking, like in between, you're like trying to find the exact, like, what's the temperature tomorrow? Will it be hot? Will it be cold? Like, you want to know exactly. Classification is like estimates, like it's just hot or cold. So you can see the diagrams there too. Okay, so decision tree is one of the most commonly used practical approaches for supervised learning. It can be used both to solve regression and classification problems. A measure of relation between the mean value of one variable output and corresponding values of the other variable, that is a regression. But classification is more unique because you see right there, there's like a little truck, or boat, airplane, or dog. So apparently the AI is supposed to be able to look at that, and it's supposed to distinguish which one is out which one, and it goes into the brain of the machine learning model, and it outputs brand new words, say boat, cat, dog, or plane. It able to recognize it, which is phenomenal. Okay, so there's so much more I can go. I can go over this whole day if I wanted to, or even 4 days if I wanted to, but I think that would be for a different day. This is a lot. Okay, this is there are pictures. So machine learning is powered by 4 critical concepts in mathematics. It's statistics, linear algebra, probability, and calculus. While statistical concepts are at the core of every model, calculus helps us to learn, optimize that model, most of all. And here's some challenges and solutions of the AI algorithm. So we discussed the challenges faced by Waymo, and there's solutions that we can solve implementing this AI algorithm. And I found this article, and it says anything better than I ever could. So AI is still learning common sense. As you know it, AI has a brain of a dog sometimes. You can give ChatGPT or some other AI program, and it'll output the wrong answer. And even Tesla model cars, they're learning obstacle avoidance. There's been like issues with it. AI is still learning, but yet for computer programmers and software engineers and other many fields, AI can smoothen a lot of the things. It can make things very fast. It can make it incredibly quick and nimble. Usually old computing tasks would take almost like, like maybe a day to solve, right? AI can do it maybe 10 minutes. I can guarantee it because of how smart it is. Infrastructure, technology, there has to be enough hardware as there is software to support AI. So I know I was talking with Professor Addington the other day. We were saying that, in order for like AI to be strong, to be as top-notch, you need quantum computing, to solve things that like could take years to solve, that can be done in minutes. So quantum computing and AI is absolutely the future. It's the way to go. Another challenge is 3D route map creation. Let's say if you were like at a stop sign, it said like 40 miles per hour, right? But somehow your system said 50 miles, you'd be like, 50 miles, that's not what 40 said. So sometimes the real data versus the real time versus the technological, it has to match. So that's going to be the important one. And cybersecurity is another important one. What if my grandma was in a car and someone was like, they hacked into the automated car? Oh, that'd be a problem because, I want my grandma to get home safely so I can see her and, someone hacks it. So that's another hazard that could happen. Sensors, it can be tricked by lousy weather. Let's say if I had, a rainy day or a sunny day, I meant a winter day, it can definitely trick the sensors, and that can be a problem big time. So, okay, so here's some of the solutions, actually chat solutions of how to solve this, because I was like, why don't we use AI to fix AI? So, so knowledge integration. So it says enhance AI models with broader and deeper knowledge base to improve contextual understanding. Experimental learning. Develop AI systems that can learn from previous experience and adapt based on real world scenarios. Human feedback. It can take receiving feedback from human users to refine and to correct the current AI systems. Scalable hardware, invest in powerful hardware infrastructures. Cloud computing, it can leverage cloud-based solutions for flexible, scalable computing resources. Parallel processing can optimize algorithms for parallel processing to improve more efficiency, and pretty much just efficiency at this point. And improving 3D map creation, we can do let's say high resolution mapping. Such as some technologies such as LiDAR or satellite imagery, which Cindy will go more over that. Machine learning for mapping to interpret complex 3D environments for accurate route planning. Real-time updates, you need to be able to see the changing conditions in a split second. So data at a second is very important because you never know what the next second holds. Cybersecurity, encryption, there needs to make sure that, gotta protect my grandma, so encryption mechanism, you'd be able to somehow to secure the car and make it strong. And there needs to be intrusion detection, of course, and regular audits, making sure, the cybersecurity team can know if any last minute happenings could happen. Another one, so sensors, weather, there should be redundancy, so there should be cameras, there should be more sensors, there should be more things that can predict if one were to fail, another could step up. So that's really important, so we need to have a couple of redundant systems. And weather prediction models, there's also need to be compensation for adverse weather conditions. So let's say if you had a prediction model, right? If it was rainy or snowy, it's turn on upgraded mode so it can detect any the worst conditions. So I'm ready to go. So the AI is very strong that day. Okay, so here's some future directions for AI algorithms and for Waymo. So Waymo's motto Waymo's mission is to make it safe, easy for people, and things to get where they're going. The Waymo driver can improve the world's access to mobility while saving thousands of lives now lost to traffic crashes. We are the driving force for the future of autonomous vehicles. Well, I hope Waymo lives up to their motto, because we're depending on it. Okay, so here's the summary of the AI algorithms I talked about. So it's a neural network regression, Bayesian regression, and decision forest regression. So what's next for Waymo? There's a picture right there on Twitter I just searched up the other day. We'll soon be testing our rider-only options without a human driver in Freeway of Phoenix. Approaching this, we've spent years operating fleets of rider vehicles across Arizona and California. That's where it started, and Cindy did briefly go over that. A couple more. And I will pass this part on to Cindy now.
So now that you heard about the Waymo's brain, let's talk about its eyes. Its eyes in this situation are going to be the sensors. You've got camera, there's radar, and there's LiDAR. So the cameras use image recognition, and it's what helps you be able to identify when a light on a street sign has turned colors to green or red. Radar is using radio waves, similar to how sonar uses echolocation, but it works in the background, and it actually is able to see when there's bad weather and maybe the camera can't see, so it's able to go through the fog to create an image of its surrounding. And the one that I'm going to be focusing on the most is LiDAR, which is light detection and ranging, which is Waymo used laser bear honeycomb until it became an independent company and started making its own technology. And LiDAR is similar to radar, except it uses a laser beam, and it hits an object, comes back, divides the time into two in order to make a 3D map of its environment. So object detection and classification. Machine learning algorithms are used to identify and classify objects captured by the LiDAR sensors. Using supervised learning techniques make it possible to learn to distinguish between a pedestrian or someone on a vehicle and other objects, and LiDAR uses point cloud data. Here is an example of the calculation of how the LiDAR uses the sensors to bounce off of an object and return back to the distance divided by 2. So obstacle avoidance. LiDAR is crucial for obstacle detection. It does use machine learning in order to analyze the point cloud data and be able to predict obstacles that could be in the way in real time. And it also uses something called SLAM, which is simultaneous localization and mapping. Localization and mapping techniques are integrated with the AI machine learning, and it allows the LiDAR data to create a detailed map and know exactly where its position is at real time.
Looks like a Minecraft, right?
Yeah. Yes, LiDAR sees the world in Minecraft. And this is machine learning application sensor data example, because while Waymo has that information pretty top secret, so we did use AI to generate what AI would look like, but in the real world scenario, the more sophisticated models with extensive data sets would be necessary. So we built something, and we want to talk to you about what we built. In order to demonstrate the importance of the sensors and how they see their surrounding, this isn't an autonomous car, but it does work on sensors, a D25 smart car. And the way this works is that for the sensors, it has photoresistors and also LED lights. The LED lights will shine onto the white background, and the photoresistors are able to see where the light is being absorbed by the dark background, and it will follow using alternating motors to determine the way to turn. So we'd like to demonstrate this for you at this time. Thank you. give Dr. Addington ours with a little. Let's, oh no. There it goes.
Told you AI is
Screw
not perfect.
Oh no. You guys didn't see that? So let's talk about some challenges. Andrew has already talked about some pretty good challenges and solutions, and I just wanted to go back and also include these for the sensors. So one of them is complex urban environments. Navigating like densely populated and dynamic city streets possess unique challenges for AI. Also, as Andrew already mentioned, inclement weather conditions. So adverse weather conditions such as heavy rain, snow, can impact the sensor's performance, as well as unpredictable human behavior. So dealing with unpredictable actions of pedestrians, cyclists, and other drivers, and regulatory legal hurdles, navigating complexity of landscape regulations and legal frameworks for autonomous vehicles, and of course, Andrew's grandma, cybersecurity concerns, addressing potential hacking and cybersecurity threats to ensure the security of the autonomous driving system. And some of the solutions. Maybe we can do advanced sensor fusion, so enhancing the sensor fusion technology to improve perception and decision-making in complex environments, weather-resisting sensors technologies, developing sensors that are more resilient to weather conditions. That's why if you look at Waymo's top LiDAR sensors, it's rotating so that dust or any particles do not affect its line of vision. And behavior prediction algorithms. Implementing advanced algorithms will help predict the response to unpredicted human behavior. Collaboration with regulatory bodies, so working closely with regulators to establish guidelines and standards for autonomous driving, and a robust cybersecurity measures, implementing robust security protocols to safeguard the autonomous driving systems from potential threats. So, in summary, sensor technologies have a strong role in using LiDAR sensors in autonomous driving for Waymo. LiDAR allows for real-time, high-resolution mapping, ensuring accurate object detection and informed decision-making in dynamic scenarios. The collaboration with the radar and the cameras enhance the overall image mapping for a safety reliable experience. And what's next for Waymo? Further advancements for Waymo revolve around refining the LiDAR capabilities, making sensors more scalable and cost-effective. The integration of machine learning and artificial intelligence will enhance decision-making. Waymo aims just for individual vehicles, but also to broaden the ecosystem developing, including connectivity and smart fusion and fostering a safe, more efficient autonomous landscape. They are also getting into agriculture and other markets, and they're obviously expanding their Phoenix location. They're coming to LA now, so you can probably experience a Waymo ride soon. Thank you.
Anyone have any questions? Any questions?
That dog is AI.
I know, right?
Just kidding. Any questions?
Do you know the cost of a Waymo, the car to go?
No, but because they're not used for personal sale, like we could never buy one, they're Jaguars. The cost is pretty high, but they're always intended to be taxis. Unlike Tesla, who has a lower cost and they're intended to be driven by people, and they still require a human driver. They're not fully autonomous. Yeah, good question.
Anyone else?
Thank you.